Hi, welcome to StatStuff. I'm Matt Hansen. In this lesson, I'll introduce you to the control chart called the P chart, used for measuring proportions. It's essential that you first review the lesson on finding the right control chart so you can be confident the P chart is the right one for your situation. But for now, let's start with a review of how to read control charts.
Well, how do you read control charts? Well, control charts plot the data points, usually using continuous type of data. Over time, they define a few things for us. They first define the observations, the data points from the data set that should be in a pre-sorted order, like a date-time order. Also, it would plot for us the mean, the average for all the data points. Also, the lower control limit, which represents 3 standard deviations below that mean, and the upper control limit, which is 3 standard deviations above the mean. Also, it would include any special cause tests, which could be any of 8 different rules that could be predefined to help identify any potential special causes in the data. So just as a way of illustration, we can look at a particular control chart example, which tends to be similar for most of the control charts that we'll be looking at. First, within this control chart, you can see that all the observation points are being highlighted here. We can see that there are 20 different observations that should be reflected here in time, like a date and time order, starting from the left all the way to the right. And then we also plot on here the mean, that is the average for the entire data set. All these observations, the average is reflected here within our sample average. Then we've got an upper control limit, which is 3 standard deviations above the mean, and then we've got a lower control limit reflected as 3 standard deviations below the mean. Then we have over here this region that falls within the red lines. This is the expected variation region, where that's where we would expect there to be some common cause variation falling back and forth around the mean, hopefully not falling outside of these upper and lower control limits, which is our unexpected variation region. That's where we might see some obvious special causes when they fall outside of our upper and lower control limits that are defined here by the red lines. And we also see in this example, there's one data point that falls below into that area. So we can say for this observation number 7, it failed the test because the data point fell outside of the lower or upper control limit area. Now, one thing to keep in mind, it's really important, is that control limits that are used in here in charts like this are not the same thing as spec limits, which is the LSL or USL. The spec limits are usually going to be tied to the voice of the customer, what the customer wants, the requirements that they set. Those are the targets. That's what the spec limits refer to. Control limits, though, are just reflecting how the process is performing, of whether it's in control based off of the variation in relationship to the mean. So it's based off of 3 standard deviations from the mean. So you can have a process that's actually considered to be in control, but not necessarily meet the customer's requirements defined by the upper and lower spec limits, and as well as vice versa.
Alright, now let's more specifically dive into defining the P chart.
Well, the P chart uses a binomial distribution to measure the proportion of defects within a sample. So it's ideal when the volume of units, that is like the opportunities, are varying within each stage, such as varying within each day, or maybe per shift, or maybe per week, or so on. So unlike using a raw percentage value, what it does is it counts for the variation in the denominator of that percentage. For example, you could have 2 different samples, each of those having a 10% defect rate, and they seem to be the same when they have the same defect rate. But it may make a huge difference if the first sample was for like a weekend day, where there was 100 total units and 10 of those were defects, again 10%. And then you have a second sample that has maybe represented for a weekday, where we might have 1,000 units, a higher volume on that day, and 10% of that would have been 100 defects. So this accounts for that variation in the actual volume and the denominator of the percentage itself. So of only the first 4 out of the 8 special cause tests that are normally available are going to be running these tests. Again, the actual lesson where we go into the details of the 8 special cause tests are in the lesson that's on testing for special cause variation within the measure phase. So what are the requirements for this chart? The plotted data must be continuous, but it should represent discrete values like number of defects. And we'll show you that when we look at the example. Also, subgrouping is expected to be a part of it since we're dealing with discrete data. So a column must identify what those different groups are. So how do I access this chart from within Minitab? You go to the Stat menu, choose Control Charts, and then select Attribute Charts and select P.
Now let's look at an example of a P chart.
So let's look at an example of the source data that you would use for building a P-chart. And what we're going to look at is that the results look really similar to the U-chart, but the difference between running this P-chart and U-chart is going to show up within the control limits that are calculated. So here's an example of the type of data that you might use. In this example we'll be displaying here, where your source data that you might throw into Minitab will look like this, where you have the different periods represented as the different groups, and then you have the total volume, which would be like the denominator, and then the errors here, or the defects, which would be like the numerator. Again, having this type of raw data like this is what makes the difference when you run it into this test, rather than using just a raw percentage value. So the output from some data like this and creating the P-chart is going to look similar to this. Now if you notice, we still have the same elements of a typical control chart. We got the average, but now you see that because of the varying proportions from day to day, the upper and lower control limits are also going to vary. So that's why you see it doesn't show up as a straight line, because you're not dealing with standard deviations anymore, but instead you're dealing with proportions. But you still have the same average, and you have the upper and lower control limits as you typically would have with a control chart like this. Now if you notice, there's one data point that does stick out. That one data point looks like we've got a high number of errors. We've got 70 errors, which really stands out compared to all the number of errors that we had on the other days. But also the volume does stand out. There's a much greater total volume for that particular day as well. So even though the number of errors seems pretty high for that day, it's still considered to be proportionally within control.
All right, before we close this lesson, let's discuss how we can apply some of these concepts in a practical way.
We'll try to identify at least 2 critical metrics you use in your organization that are based off of discrete values, and see if you can get some historical data for that using at least 20 different data points and run that through a P-chart, and make sure that the data you're using is similar to what we showed in the example of how it's set up, and at least that it's sorted as well historically, so that the oldest values are at the top and the most current are down at the bottom. Then ask yourself a few questions for each of those metrics that you're evaluating. First of all, was there any data point that did fail the first test, that is, where it fell outside of the lower or upper control limits are defined? If so, then can you explain what caused that particular failure? And does it appear to be a special or maybe a common cause type of failure? Now, if there were any failures that were noted, then what are the actions that should be taken to help fix those errors and help prevent future failures?
Well, that wraps up this lesson. Check out StatStuff.com for many more resources that can help you achieve powerful results. I'm Matt Hansen. Thanks for watching.